This lesson is about using logarithmic and exponential functions with bases other than e. The definition of an exponential function with base a is the following. A to the x is equal to e to the ln of a times x. And here's the proof of that. If we're given e to the natural log of a times x, we know by our natural log properties, we could rewrite this as e to the x ln of a, which is e to the ln of a to the x power. So this is just the coefficient power rule. And then finally, e to the natural log, these are inverses. And we know since these are inverses, they're just going to equal a to the x power. So there's your proof. A to the x is equal to e to the ln of a times x. The usual laws of exponents still apply here. So anything to the 0 power, no matter what the base is 1. Also, when you're dividing anything with the same base, you simply subtract the exponents. So this would be a to the x minus 4. If you're multiplying anything with the same base and they have powers, you add the powers, so it's a to the x plus 4. And finally, if you're raising a power to a power, no matter what the base is, you multiply the powers. So it's a to the 4x. Okay, so just the basic usual laws of exponents that you know of. The definition of a logarithmic function with base a, we would say log base a of x is equal to 1 over the natural log of a times the natural log of x. And so to prove this, we can start with that expression 1 over the natural log of a times the natural log of x. And this is equal to the natural log of x over the natural log of a. And remember, the natural log is simply log with base e. So it's log base e of x divided by log base e of a. And then if you remember learning in pre-calc or algebra 2 about the change of base theorem, the change of base theorem allows me to rewrite this as log base a of x. And there you have it. 1 over ln of a times ln of x is equal to log base a of x. All right, just recall the usual properties of logs. The log base a of 1 is just 0. This means a to the 0 power is 1. Okay, secondly, the log base a of some product, x times y, is equal to the sum log base a of x plus log base a of y. Okay, third, log base a of x to the n power is our power rule. We can bring that power in front and write it as a coefficient as n times log base a of x. And then finally, we have our division property. So if we have log base a of, let's say, for example, x over 4, we can rewrite this using subtraction as log base a of x minus log base a of 4. All right, a quick review of solving some of these logarithmic equations would be 3 to the x is equal to 1 over 81. So in this case, you're asking yourself, what power would I raise 3 to get 1 over 81? So in this scenario, it's going to be a negative exponent. So it would be x equals, well, 3 to the what power is 81? That's 4. So it would be negative 4. All right, a second example. Let's say I had log base 2 of x is equal to negative 4. This is you saying 2 to the power of negative 4 equals what? So 2 to the power of negative 4 is 1 over 2 to the 4th, which is 1 over 16. Okay, we've seen the derivatives of e to the x and the derivative of natural log of x, but what about the derivatives with bases other than e? For example, the derivative of a to the x. So the new derivative rule for this is similar to the derivative of e to the x. You repeat it, so it's a to the x, and then you always multiply by the natural log of a. Using chain rule, let's say it wasn't just x. The chain rule, so the derivative of a to the u, where u is some function of x, would be a to the u multiplied by the natural log of u. And then since it's chain rule, this is some function of x. We have to multiply by the derivative of that. So the derivative with respect to x. Okay, so if I had the derivative of log base a of x, this is simply going to be 1 over x times the natural log of a. That's it. So chain rule, if we had the derivative with respect to x of log base a of u, where u is some function of x, this would be the same thing, 1 over u, whatever that function of x is, times the natural log of a. But then it's chain rule. We have to multiply by the derivative of that function u. So we multiply by the derivative of u with respect to x. Yay! All right, finally we do have an integral rule. If we are taking the integral or the antiderivative of a to the x power, this is simply going to be 1 over the natural log of a times a to the x. Don't forget the plus c. Now remember, if this happens to be something other than just x, right? Let's say it's a to the, 2x squared or whatever. That's when we have to use our u substitution. So now that you have the derivative and integral rules, let's practice a couple examples. All right, let's look at some examples now that you have the rules. So first and foremost, let's say I asked you to take the derivative of 2 to the x power. Well, this is simply 2 to the x power multiplied by the natural log of a, in this case, which is 2. That's it. Number 2. Let's say I give you y equals 2 to the 3x. I want you to pause the video and think about how you would take the derivative using the rules. It would just be 2 to the 3x multiplied by the natural log of 2, but then we also need to multiply by the derivative of the power, so the derivative of 3x, which is 3. So all together, we just have 3 times 2 to the 3x times the natural log of 2. And we could clean that up a little bit, but that's the derivative. Another thing to remember before I do this next example is if you just see log of something, not the natural log, which is log, and there's no base written, the implied base is always 10. So whenever you see just the log with no base written, the implied log is 10. All right, for the third example, we have y equals log of cosine of x. Now remember, when you have just log, the implied base here is 10, so you can write that in. So now this is going to follow that fourth derivative rule that I had given you with the chain rule. So the derivative of this is simply 1 over cosine of x times the natural log of the base, which was 10. And then don't forget, we have to use chain rule here and multiply by the derivative of cosine of x. So the derivative of cosine of x is negative sine x. That's your derivative. Finally, I'll just do a quick integral example using the integral rule I gave you. If I wanted to take the antiderivative of 2 to the x, using the rule I had given you, it's simply 1 over the natural log of 2 times 2 to the x. Don't forget about the plus c. Alright, that's it for this lesson. We will work more with bases other than e and applications of this later. Thanks.